to another video. It has been a long time coming. I want to appreciate all my subscribers. I want to appreciate all those who have been sharing my videos and participating in actively and learning all that I've been teaching. I want to say thank you to each and every one of you. I sincerely appreciate all your comments, positively, and criticisms. I take them as a stepping stone to success, so I really want to appreciate you. In today's video, I'll be taking us through how to predict. It is actually a machine learning video. So in this particular project, I want to predict if a patient has diabetes or not. So we have a very large data set, and this is a continuation of the video on data transformation. So this particular data set on diabetes, it has been transformed already. So we'll go straight into the machine learning modeling. I'll come to my browser here. It has already been opened. I will open a new Python file. Okay, so this is the cell. Let's wait for it to load up. Okay, so the first thing I want to do is to import the necessary libraries. Okay, so I want to import pandas as PD. Then I want to import numpy as np. Okay, shift and enter will run. So we want to now read the file. So name it df data frame is equals to pd dot read underscore csv. Okay, and then since the file is in the same file path as the Jupyter Notebook, I'll just copy it here, Ctrl C, and then I'll paste Ctrl V. So I want it to give me the top rows, shift and enter. Okay, so this is the transformed data set. So now the next thing I want to do is I want to actually assign the variables. Okay, I want to assign the variables. Okay, now I will assign the variable x to be equal to okay, but before that, before I assign the variables, I discovered that there is a column here which is unnamed, more like the index. So I'll have to delete it. So let me find out the unnamed. So in deleting, I'll say df1 equals df dot drop. Okay, I want it to drop unnamed. Okay, I'll just. Okay, and then I'll run this. Let's see what the problem is. Not found on axis. Okay, let's say axis equals 1. Okay, so it has gone. Now let's see what df is. Df is dead. Okay, so the index has gone. So now the next thing I want to do is to continue in assigning the variables. So I'll quickly take this up. I'll bring this down. Okay, let's assign the variable. Now we are assigning the variable x will be equal to df.drop. We'll drop the outcome feature, and then we want the axis to be equals to 1. Y is equal to df, and then the outcome that we are dropping in x, df1, in outcome that we are dropping in f is what will be the variable of y. So as we are dropping this outcome, you see this outcome here, the outcome is actually what we are trying to predict. So we want to predict that the patients that have this data on pregnancies, on glucose, on blood pressure, on skin thickness, as diabetes. Having diabetes is 1, and then do not have diabetes is what? Is 0. So we want to predict that. So in order to predict that, we have to do what? Remove this outcome from the x variable and then make it the y variable. So then we run. Okay, so it has actually been run. So now the next thing we want to do is to import. We want to import the classification algorithm to use. So in this particular project, I'll be making use of the random forest classifier, So I'll say from sklearn dot ensemble import random forest classifier. Okay, and then we'll assign the classifier to a variable which we'll call CLF. You can assign it to anything. You can give it let's say CLF means classifier. It's just a short form for classifier. Okay, let's leave it CLF. So this is equal to random forest classifier. Okay, and then we'll call it. So we are calling the function random forest classifier. Now you may be wondering, why did I use random forest classifier? Now the random forest classifier is actually a very unique AI model, in the sense that it works by classification. And apart from the fact that it works by classification, it is a kind of the father, okay, of different classification systems. So each classification systems classify data in the classify the data points in the data set and produces its own result. So different classifiers produce their own result, and then those results are now compounded using the random forest classifier. So it's a kind of an altogether classification system. So it is not just one way. It brings into cognizance every unique data points in the data set. So that is why we use random forest classifier. So now we'll run this. So while it is still running, we want to split the data set into train and test variables or features. For that, we'll call in the train test split function from sklearn dot model selection. We'll import train test splits. Okay, so as we import it, then we'll say x underscore train comma x underscore tests comma y train comma y tests. Okay, so train test splits, we'll call in the function now. Train test splits, train test splits function. Okay, so we'll say help us to train this and this, and then also once the test size to be equal to 0.2. So now when we talk about train test split function, so what happens in machine learning is that you feed in the algorithm with data sets. Now that data set which you use to train the model is called the training data set, or is called the train variable. And then by reason of you training the model, then a part of the data set is used to test the results of training the data set, of training the model. Is used to test the should I say the accuracy. Is used to test how far the model can perform. So that is why we divide it into training and testing what variable. So now it is advisable to use a large chunk of the data set to train the model, and then use a little to test it. So when we talk about the test size, I'm trying to say, okay, this is 0.2, meaning 20%. I'm trying to say, okay, use 80% to do what? To train the data set, and then use 20% to do what? To test use to train the data set, and then use 20% to test the model, whether to test the accuracy of the modeling process. So that is just what it is. And then we'll run this, Okay, so the next thing that I want to do is to fit in the model. We want to fit in the model. Now to fit in the model, we'll call the variable, which is the CLF, okay, dot fit. So we want it to fit in the X train, okay, that we use in training the data set, and then the Y train, okay, and then we run. Can you see that? So it returned the random forest classifier. So now the next thing we want to do is our prediction. Yes, that is the main aspect of it. You want to predict our X test. So in predicting the X test, we want to say Y underscore threads will be equal to CLF dot predict underscore X test. Can you see that now? So we are using the predict function to predict the data set that we want to do what? To test on. Now let's look at this together. So we have Y threads. When we run this, let's see. Okay. Now we want to look at the score, the accuracy score of the X train and the Y train. So this is the data. This is the variable that we use in training the data. So we want to see the score. Normally, the score is supposed to be 1. Yes, because it is what we use to do or to train the model. So it's supposed to be 1.0, meaning 100%. 100% fully was used to train the model, to train the classification model. Now when we run this, okay, can you see that it is what? It is 1, meaning 100. So now I want to now check for the tests data sets. We have looked at this, the train data set. Let's now predict for the test data set. Okay, here we go. Oh, okay, so we can see here that it is 78%. Okay, so the accuracy is 78%. That means that the model was able to predict if a patient has diabetes. 98% accurate. It is it is 78% accurate, please. It is 78% accurate. So that is how we can be able to predict the outcome of a data set using machine learning, particularly the random forest classifier. Now I want to check the metrics. It's very important to check the metrics. The metrics gives you a kind of a breakdown of the performance of the model. Check the metrics of the model. Now, in order to check the metrics of the model, we'll use the function from sklearn dot metrics report confusion matrix, accuracy score, classification reports. So we want it to print for us the classification report on Y test Y threads. Okay, so let's see. This is for the classification report. So the classification report is used to measure the quality of prediction from a classification algorithm. So what it is trying to say is it will check how many predictions that are true and how many predictions that are false. So you can see here precision, that is the degree of how precise it is in calculating positives and negatives, and then you also look at the recall. So these are the classification reports. Then the next we want to check is the confusion matrix. The confusion matrix. So we say confusion matrix, Y tests, Y threads. Okay, we run this. Okay, so this is the confusion matrix, and then the next is the accuracy score. Accuracy score. Okay, so it is still same score we got here. This is what it is. So this is the accuracy score. Now one thing you have to know is that these scores can actually be improved upon, and also apart from that you can make should I say a kind of the score to change, in the sense that you can come to the test size here, and let's say we increase this to 3. We increase it to we increase the training the test size. Okay, we want to increase it to 30%. We want to use 30% to test the model. So we'll run this again, and then we run this. Run this afresh. So let's run this. Let's see. Oh, okay, so it has actually reduced. So I guess we'll have to leave it at the 2%. That is 20%. Okay, so that is 75. So these are, so you can see that the values are changing as I effect changes on the test size. The accuracy of the model will also be affected. So that is machine learning processes for you. So you just have to be able to know what you want and try to make adjustment to it, and then run this and then run this. So lastly, we want to save the model. Now in order to save the model, there is a function for that, which is called people. So we are going to import people, and then we say people dot dump. Okay, we're calling the function dump dot clf. We open, and then we'll call this a name. Let's give it random forest classification. Transformed data. Okay, dots pkl. So that is the extension, and then we are writing into it. Let's run this. Let's see. Okay, so it has successfully run. So let's check the okay, so you can see here, so this is the model pkl file. So I hope that we've been able to learn something new today, and please I'll send this to my GitHub page, so in case you want to go through it, you can also go through it. Thank you very much for sticking till this time. I remain Samist the analyst. Please, if you enjoyed the video, do to subscribe to my channel, share the video to as many who are looking forward to a career in data science or in data analytics. And I do hope that you enjoy your stay. Thank you. Until I see you next time. Goodbye.